Shall we start? Shall we start?
Yes, sir.
Okay. So we start 2 minutes. So can you able to see the screen?
Yes, sir.
Okay. Okay. What is the last topic we discussed? Mechanical. What type of system? Previously we discussed it. What is the name of the system? So what type of discussed is this one?
Translation systems.
Yes, translational system. Exactly. So now we are going to discuss the mechanical rotational system. Okay. So previously we discussed the translational. Now we are going to discuss the mechanical rotational system. So exactly the same analysis, same procedure, and same exactly the only three parameters we are going to discuss in the rotational system. So previously we discussed mass, dashpot, as well as spring. The same thing, three of them, but slight change in the three parameters applicable for the rotational system. So the first one, mechanical rotational system, you listen carefully. The mechanical rotational system is obtained by the same three elements. Here the one difference is moment of inertia. That is for mass, here we are considering the moment of inertia. So that is represented by J. So this J is considered as a instant of M. So this is the only difference. So, and then second element is dashpot. That is the frictional coefficient P. And then the last one, as usual, the torsional spring, it is K. So these three elements the same exactly to the mechanical transfer system, but the one difference is here we are, since the system is a rotational system, so we are considering the moment of inertia. So these three parameters are going to consider for the mathematical modeling of the mechanical rotational system. So and then second paragraph, what you are expressing here, the weight. The weight of the mechanical system is represented by the moment of inertia. There, what we have expressed as a symbol as m, mass is, here it is represented as a j. So here we are concentrating the center of the gravity of the body. The same thing, elastic deformation, which is represented by the spring, and the dash part is used to represent the friction. The same thing, because here the same liquid is filled at a high compressed pressure. So here we are considering the dash part is used to represent the compression of the fluid. So as per the Newton's law of motion, every action there is a opposite action. So the whatever the force you are applying, there is always a force against to your applied force. So here what is the difference is, we have to consider the torque. So in the mechanical translational system, we have considered what is the applying force and what is the opposing force. I hope you remember what is the applied force and what is the force against your applied force. Here the difference is you have to look out the torque. What is the applied torque? What is the opposing torque? So there we used the symbol F. F represents the symbol for force. Here you have to consider for the mechanical rotational system. The mechanical rotational system, it is represented by opposing torque as well as the applied torque. So the same Newton's second law of motion we are considering, but the difference is rotational system. So for the rotational system, we have to consider, or we have to talk about what is the applied torque and what is the opposing torque, similar to applied force and opposing force in the mechanical translational system. So what we have so far discussed, mechanical rotational system. Rotational means it is a rotating object. So it consists of three parameters to model the mechanical rotational system. The first one is inertia, moment of inertia, which is represented by J instead of M. Second one, dash spot P, and third one, spring K. So the three parameters, you know how to model, how to write the differential equation for the individual elements as in mechanical translation system. So here, what is the another difference? Since it is a rotational system, we have to discuss about the torque. So what is meant by torque? The definition of the torque is twisting or turning moment. What is meant by torque? It is means twisting moment or turning moment. So that is called as a torque. So what is the unit of the torque? Newton meter. So here you have to consider what is the applied torque and what is your opposing torque. So exactly the same principle, write the differential equation for applied torque, write the differential equation for opposing torque, equate the two torques and simplify the differential expression, and finally apply the Laplace transform and find out output of the system divided by input of the system. So any doubt in this? What is the mechanical rotational system? Any doubt? Mechanical rotational system. Shall I move next slide?
Yes, sir.
Yes.
So, so I hope you remember this slide for mechanical translational system. So here the mechanical rotational system, here you have to consider the angular displacement theta. So and then again angular velocity. If you take the derivative, the first derivative, that is called as angular velocity. So the first one theta represents the angular displacement. So if you take the first derivative, that is called as angular velocity, and the second derivative is called as angular acceleration. So one more difference is applied torque. There we consider the applied force. So there we consider the applied force. Here I have to consider what is your applied torque. So then instead of mass m, here it is represented as J. Since it is a rotational system, so moment of inertia should be considered, and the unit is kilogram meter square per radian. And then as usual, remaining two is exactly same. Dash spot B as well as the spring constant, that is K. So these are the symbols you have to use for mechanical rotational system. Don't use the force as well as the mass m here. It is replaced by moment of inertia J as well as the torque, applied torque as well as opposing torque by T, capital T. Okay. So any doubt in the symbols? What are the symbols we have to use? So instead of theta, what we have previously used in the mechanical translation system? Instead of theta, what we are
X.
Yes, exactly. X is the displacement in mechanical translation system. How much distance moved? Here, how much of the rotation, that is displacement, is angular displacement. So any doubt in this? Shall we move next slide?
Yes, sir.
Yes, sir.
So As usual, what we previously discussed, it is a force balance equation. What's my force balance equation? Your applied force exactly equivalent to the opposing force. Here, it is a torque balance equation. So what it is called as, it is a torque balance equation. So what is my torque balance equation? Applied torque equivalent to the opposing torque. So this torque balance equation will be applicable for the rotational system. So previously we discussed the force balance equation. Now we are going to discuss the torque balance equation. So now you see the system. So this is a system. Instead of M represents the weight here, the J represents the moment of inertia. So the T is called as applied torque, and theta, based on the applied torque, how much the angular displacement happened, that is represented by the theta. Now the T is the applied torque, that is the torque we are applying, and the Tj represents the J opposes the torque for your applied torque T. So that is called as T suffix J opposing torque. Now as same as in the mass element, that is mass, it is a double derivative. That is two derivative you have to take. I have given some explanation why it is a double derivative. Mass, the weight will be shifted from positive maximum to negative maximum, and it is tilted between these two levels. Therefore, it is taken as a double derivative. Therefore, the same as the force, here the torque T suffix J is d square theta by dt square, and the constant of the proportionality which is given as J. The J is nothing but a moment of inertia. So therefore, the applied torque equivalent to opposing torque equivalent to J into d square by d square theta by and dt square. So this is similar to the mass element. So what is the second element? So first we discussed the moment of inertia J. What is the second one? So the first one is the torque, that is moment of inertia J. So what will be the second element, mathematical model? So what will be the second element? What is the next element for mechanical rotational system? So it represents the dashpot element. Next we are going to discuss the dashpot element. So the T is the applied torque and theta is the angular displacement, and the B represents the dashpot element. So now the TB, T suffix B, which represents the torque for the dash element. So the TB directly proportional to d theta by dt, similar to the translational system, and the constant of the proportionality for the dashpot element is B. So TB equivalent to d theta by dt. So as per the Newton's law, second law, applied torque equivalent to opposing torque equivalent to B into d theta by dt. So if there is two displacements, that is angular displacement theta 1 and theta 2, what will be the equation for this system?
Theta 1 minus theta 2.
Theta 1 minus theta 2, exactly. So you have to take here, there are two angular displacement. So see, for angular displacement, it will be represented by theta 1 and theta 2. Therefore, for back, that is dashpot element, represented by TB equivalent to B into d theta by dt. That is, the theta is represented by theta 1 and theta 2. Theta 1 as well as theta 2. So therefore, applied torque equivalent to opposing torque equivalent to B into d by dt into theta 1 minus theta 2. So there we are using force, here we are using the torque. There we are using the, that is displacement x1 minus x2. Here we are using the angular displacement, that is theta 1 and theta 2. And the next one is spring constant, it's represented by K. So here we are discussing instant of force, it is considered as a torque. So you see that the torque, the ideal spring with one fixed reference, and then it consists of the displacement at the both ends. So for this diagram, first one, that is one fixed reference, the T is the applied torque and the Tk represents the opposing torque. Therefore, opposing torque is directly, that is opposing torque T suffix K is directly proportional to theta. The constant of the proportionality which is represented by K into theta. So here it consists of two angular displacement, theta 1 and theta 2. So which is represented by applied torque equivalent to opposing torque equivalent to K into theta 1 minus theta 2. So instant of x1 minus x2, here we are discussing the angular displacement theta 1 minus theta 2. So these are the guidelines. I hope the guidelines is already we discussed in the mechanical translation system. The same system, same procedure. First, you have to consider the node. Here, the node is J instead of M. So here, the node is considered as the same concept. Node, what is my node? It is a meeting point of the element. There, we consider the mass M. You have to look out which is the what are all the masses are given in the system. Here, you have to consider what are all the J moment of inertia are considered in the system. So look out the J term and find out what are all the other elements connected to the J system, that is moment of inertia. And as usual, write the differential equation for each element, add the differential equation on one side, that is opposing torque on one side, apply the torque on another side, and apply the Laplace transform, simplify the differential equation to algebraic equation, and find out the output of the system divided by the input of the system. Same principle, draw the free body diagram for the each J system, find out the connecting element with each J system, write the differential equation, add the term, apply the Laplace transform, and equate it. So that is the concept that is it is given in the text. Free body diagram. You have to take the Laplace transform and convert the differential equation into algebraic equation by applying the Laplace transform. Then equate the terms. So see the Laplace transform. Previously we considered the x. Here we are considering as a theta. So it's showing the angular displacement and how to take the Laplace transform for the first order derivative and Laplace transform for the second order derivative. That is s square theta into s. So if you have still have doubt in the Laplace transform, how to take the Laplace transform means, please go through the Laplace properties, Laplace transform properties, because this is a simplified expression for the Laplace. Here we are discussing only the first order, second order derivative, but in the coming chapters, we need you have to go through the various properties of the Laplace transform, especially the exponential as well as the time domain. You have to go through what is the Laplace transform for exponential term, e power x term. Okay, so please once again go through the properties of the Laplace transform. So now come to the problem. You please take down the paper and pen, draw the diagram, and tell me the or post the answer in your chat box. So please take the pen and paper, draw the diagram, and tell me what is the first step. What is the first step? You have to consider the J term. Previously we had discussed the M term. Here you have to consider the J term. So first, what is the first step? You have to draw the free body diagram for J1. Next to free body diagram for J2. Derive the differential equation, apply the Laplace transform, and then finally find out the transfer function of the system. So can anyone tell what is the output of the system and what is the input of the system? What is the output of the system? So obtain the transfer function of the given system. What is the output of the system and what is the input of the system? It is straight away given in the question itself.
Theta is output and T
is the input. Yes, exactly. Theta, that is this theta is the output, that is angular displacement, and applied torque T is the input. So what is the transfer function of the system? Ratio between, what is the transfer function?
T by T.
Yes.
T of S by theta.
Theta by T or T by theta?
T by theta.
T by theta. Output by input or input by output? Yes,
theta
by T.
Theta by T.
Theta of S divided by T of S. Okay. So start solving the problem. Shall I move to the next slide? So first draw this diagram. Please take the pen and paper. Please draw this diagram first. So any questions, please post in the chat box.
Sir?
So first draw this diagram.
Sir, for the spring in rotational motion, it won't have a displacement in linear motion.
Yes, it is a rotational angular displacement.
So like in linear also it will have some displacement for the spring.
See, it is a rotational system, right? It is a rotational system. How there will be a linear displacement? For rotational system, we are considering the angular displacement.
Okay, sir.
It is a rotational system, not it is a translational system. transmitting from one space to another space. It is not a translational. It is considering the object is fixed, but it is a rotational one. So we have to consider the rotational displacement. Okay. Whether you understand the concept or not. Have you studied the LVDT? LVDT, linear variable differential transformer.
Yes, sir.
So what is that? It is the linear displacement. And same thing, we are having another one, RVDT, rotational variable differential transformer.
Okay, sir.
Similar to that, it is a linear as well as a rotary motion. It is a linear motion translation system, and this rotational means it is a rotational displacement. So please
okay.
first draw the diagram. What is the first step? What is the first step?
Make free body diagrams of J1.
Yes, exactly, man. So draw the free body diagram considering only which term you have to consider? J1. So draw the free body diagram for J1.
J1.
So please practice the problem. This is the core subject for you. This is only main concept, main subject in GATE examination. Now you are in the second year. In third year or fourth year for competitive exam, control system is important part. So please don't, Lata Jake, you please take the pen and paper, then and there you clarify the doubt. Take the pen and paper, draw the problem first, understand what is the question it is asked. Feel free, if you have any doubt, please ask the question, okay? So once you draw the problem, tell me, I will move on to the next slide. So once you have finished the problem means you start proceeding the answer. Draw the free body diagram only for J1 and find out what are all the connecting elements with J1 and write the differential equation, and you go ahead with that. So those who are still stuck on this, tell me once you draw the problem, I will move on to the next slide. So those who have proceed further, you can cross-check the answer with the slide.
Sir, next slide, sir.
All of you finished? If there is any objection, or moving to next slide.
You can move,
Sir, wait, sir.
Okay, man. I will wait. So draw the problem. Understand what is my J1, what is my K, what is B, what is theta, and what is the reference point. The slash is showing it is a reference, a fixed point. This shows the fixed point. Shall we move next slide?
Yes, sir.
Okay. So what are the connecting elements with the J1?
K.
KT, another one is
Mass.
KT and theta.
yes, exactly, man. Who told the answer? Exactly. Theta. That will be considered as theta 1. Okay. So it is a solution. So you please note down the required transfer function is theta by T of S. The required transfer function is you have to find out theta of S divided by T of S. So theta of S is the overall output. But for J1, we are having theta 1 also. Okay. This theta 1 is for J1 and theta is for J2. So please note on what is the problem. We have to find out theta of S divided by T of S. Theta 1 is for J1. For J2, it is theta. For J2, it is theta. J1 is, you have to assume it is a theta 1. Okay. So in the problem, they want to give us theta 1. You have to assume this is theta 1 and the final element is theta. Suppose if there are J1, J2, J3 means J3 is theta and the first one theta 1, theta 2 and then theta. Okay. Shall I move next?
Wait, sir.
Okay. So please note down only the required transfer function. What is maybe output of the system theta of S divided by input of the system is torque. Shall we move to the first one? J1, free body diagram.
Yes, sir.
So you see the first one, the first free body diagram, the theta T1 and Tj1 and Tk. So you first draw the free body diagram for the J1. So T, that is applied. This T is applied, and theta 1, it is a applied one, and Tj1 and Tk, both of them are opposing. That's only the arrow mark is given against the applied one. So please understand the symbol why their arrow mark is against one. One is clockwise, another one is anti-clockwise. T, capital T and theta 1 are applied torque. Tj1 and T suffix K is a opposing torque. That's why the two arrow marks are anti-clockwise. Okay. So first draw the free body diagram. If you miss any one of the term, the final expression will be wrong. Okay. If you miss any one of the term in your differential equation, the final answer will be wrong. So don't miss anything. It is purely how we are thinking about the imaginary, because theta 1 is not given directly, Tj1 also not given directly. You have to consider this torque in both applied as well as opposing. So the first one, Tj1. First you have to write the Tj1 equation. So the Tj1 is J1 into d square theta 1 by dt square, and Tk, that is k into theta 1 minus theta. That is, you have to start from the left hand side, theta 1 minus theta, not theta minus theta 1, because you are considering only the J1. Therefore, it is theta 1 minus theta. So then, as per the Newton's law, what is that? Applied torque equal to opposing torque. Therefore, T is the applied torque, opposing torque is Tj1 plus Tk. So add the differential equations, then apply the Laplace transform. So please don't copy, you practice yourself, apply the Laplace transform. If you cross check with that whether you are getting the right answer or not. So this problem is only based on practicing how you are applying the Laplace transform. It is easy to write the differential equation, but once you are applying the Laplace transform, you will face the difficulty. How to transform the differential equation into algebraic equation by applying the Laplace transform. Okay, whether you are getting the equation 1 and equation 2.
Yes, sir.
It is over. Equation 1 and equation 2.
Yes, sir.
Shall we move next slide?
Yes, sir.
So
Okay,
next for J2. So J2, you please draw the free body diagram J2. So J2 first theta is only the applied force. That is the only applied side, and remaining the three terms are opposing side. Tj2, Tb, and Tk are opposing side. So write the differential equation for the three and make the applied torque on one side, opposing torque on another side. So since there is no applied torque, therefore it is considered as a zero. Only there are opposing torque. You see that there is no applied torque on J2. Only the opposing side also. Only there is opposing side Tj2, Tb, and Tk. So write the differential equation and take the Laplace transform. So any doubt in this? There is no applied torque for J2, only opposing torque for the J2 side. So check we are getting these two equations or not. So understand that here we are considering the J2 side only. Therefore, it is theta minus theta 1, not theta 1 minus theta 2. We are considering from J2 side. Therefore, it is theta minus theta 2. Theta minus theta 1. So which side you are considering first? From that side only you have to start the assumption. That is theta minus theta 1. So if you have any doubt in this, how to draw the free body diagram for J2 or how to mark the applied torque and opposing torque. So please raise your questions. Maybe the same question, some other students also have the same doubt. Don't hesitate. All are here for only practicing and learning.
Again, explain how this convention of theta minus theta 1 should be.
Theta minus theta 1, because we are considering only the J2 side. What is the J2 side angular displacement? Theta minus the previous one.
Theta.
That is theta 1. See, we are considering only the J2. J2 one, we are drawing the free body diagram only for J2. So what is the angular displacement for J2? Theta. So theta minus the previous one, minus theta 1. Okay.
Sir, if theta and theta are in opposite direction, then we will take the sum of both.
No, theta and theta 1 are not in opposite direction because of the rotational system, the same direction.
Okay. Okay.
You understand that? See, J2 will be rotating clockwise and J1 will be rotating anti-clockwise. It is not possible practically, right? Both the J1 and J2 rotate in the same direction. Any doubt?
Okay.
Just remember that if you are moving the object,
No,
translation system, x and x1 will be in the same direction movement. It will not be in opposite direction. Direction of movement is same. So same thing, rotation also in the same direction.
Okay, sir.
So you have finished this, everyone. Shall I move to the next slide?
1 second.
Yes, sir.
1 second. Okay, no problem.
Sir, will they ask us to find anything else other than transfer function?
No, only for this kind of problem, mechanical translation system, mechanical rotation system, only transfer function. See, the question may be, obtain the transfer function, output by input, sometimes which output, which input, that also will be changed. Okay, here the output by input, the output is theta divided by t of s. Sometimes you need to find out only theta 1 divided by t. So they will specify the expression directly. You have to find out that only, that output by that input. Okay. So you have to find out which output by which input. So here theta by t, sometimes theta 1 by t, that is enough. Like that they will ask the question directly, theta 1 by t or theta by t of s.
Okay, sir.
Shall I move next slide? Shall I move to the next slide?
Yes, sir.
Okay.
Yes, sir.
So based on the previous expression, you will get the theta 1 of s. But our objective is to find out the theta of s. Okay. Theta is the final output. Theta 1 means it is the output of the J1. So what is the overall output? Because we have to consider which point is a reference point, which point is a fixed point. That is the final output. So based on the fixed point, reference point, theta is the final output. Theta 1 means it is the output of the J1 system. So here you have find out the theta 1 of s. So based on this, you have to find out the theta of s divided by t of s. So you please cross check the answer. Substitute the equation 3 in the equation 2. This is the equation 2. I hope you have noted the equation 2. In the equation 2, substitute the equation 3. You'll get theta of s by t of s.
So that theta is by t of s, that is the
That,
transfer
yes,
function,
this is
right?
the final transfer function. Asked the question. Suppose if they asked theta 1 of s by t of s means you have to find out theta 1 of s divided by t of s.
Oh, okay, sir.
So here the k represents the spring constant, j represents the moment of inertia, and the b represents the dashpot coefficient. So what is this s? S represents s equivalent to small s equivalent to j omega. That is your time domain is shifted to frequency domain. That is differential equation is transferred into algebraic model. The small s, s square, s. What is my s? S small s equivalent to j omega. That is time domain variable is transferred into complex frequency variable. So what we are inferring from
So
this?
J
Why we
means the
need
direction.
what, man? Hello?
J means the direction, sir. So J means.
J means moment of inertia. Capital J.
Sir, in that translation motion, like S means what, sir?
In translation, we consider the m. Instead of J, there is m. Mass weight.
M omega.
J. See here.
So there is M omega.
Here we are considering J. There we are considering m.
Okay, sir. So
Here
then the S equal to, like in
S
translation
equal-
motion, what is S?
same S. J omega. Small J omega.
No, sir.
In translation,
In
both
S
in translation also the same concept. In translation as well as in rotational, in both the system, small s equivalent to j omega. Okay. S equivalent to
Sir,
J
like
omega.
S means the moment of inertia.
Not
In
you see,
translation motion,
S equivalent to
yes,
J omega.
yes, sir,
Okay.
yes, sir.
The same S is applicable for translation system also.
No, sir. I'm asking what the J indicates.
J complex variable, complex variable.
Yeah, like the
J is the
direction.
complex. Light in the
Okay,
you studied in the mathematics. Complex variable J.
okay, sir. Okay, sir. Okay, sir.
So what we are inferring, this differential equation is converted into Laplace variable, that is algebraic model. Time domain is converted into frequency domain. See, this is the transfer function for this system, right? So you can write the transfer function for any system, each and every one. That is 56 students. For each student, you can derive the transfer function. What is the output of the particular student? What is the input of the particular student? So for each student, the transfer function will be vary. So based on how you are assuming what are all the parameters of the human body, that is particular student. So based on that, you can derive this transfer function for each and every student. So after obtaining this transfer function, what can we do? Yes, I had derived this theta of s by t of s. What I am going to do with this transfer function? Any idea? Yeah, any question? Okay, sir, we have derived this transfer function, output by input. What I am going to do with this transfer function?
Like all system are converted into a common time domain.
Yes, okay, that is converted into frequency domain. Time domain is converted into frequency domain. So in the transfer function, you see that the k is a constant, b is a constant, and j also a constant. So if you change this constant value, you can get one conclusion. So for this value of constant, we can get the better efficiency or better performance or better result for the system. So based on this expression, you can change the constant for this system. You can get a one conclusion as a control engineer. Okay, if this is the value we set as a constant, this is the output performance of the system. So by this way, you are going to design the system. So this is called as control system design. Okay, because theta is the output, t is the input. You know what is the output of system, what is the input of system. By changing the output by input, you can get one conclusion for which value of this constant we can get or we can improve the efficiency or performance of the system. So that's why I told you, you can write the transfer function for your own. You can write the transfer function for your body. So from that you can change it. Which one can be changed so that we can improve the performance of the individual student. So transfer function can be write for not only for the mathematical mechanical system, you can write for the human body or any electrical system or any system, you can write the biological system, any system you can write the transfer function. So whether you got this expression theta of s by t of s. Shall we move on to the next slide?
Yes, sir.
Yes, all of you have finished. Is there any objection? Shall we move on to the next slide? No.
Yes, sir.
So I hope this is the result. So you have to present the result of the problem like this way. So what is the first differential equation? That is, you have drawn the first free body diagram. What is the differential equation for that system? Second one, for the second free body diagram, what is the differential equation for the system? And finally, after applying the Laplace transform, what is your overall transfer function? Okay, so first one you have to write the differential equation, and second, what is the differential equation and what is the transfer function. So while we are evaluating the answer, whether it may be only MCQ or you are coming to write the 3 hours exam, we will see only the expression. If you missed any one term in this expression, based on that the mark will be reduced. So in the assignment, you have submitted the assignment. So today only I am going to evaluate the assignment. If any one of the term is missing, based on that, out of 10, the mark will be reduced. Okay. So any doubt how you have to present the result for the system, result for the given problem? So whether the expression is right, theta is S by T of S. Can I move on to the next slide?
Wait,
Yes,
sir.
sir.
Okay. So this is your homework problem. You take down the problem and solve the problem. So first write the equation, write the differential equation that is governing the mechanical rotational system. Understand this is a rotational system means everything comes to your mind J, B, K, theta instead of X. And instead of force here you have to consider, you have to write as a torque. There it is a applied force, here it is a applied torque. So understand the question, it is a translational or rotational system. Determine the transfer function theta of S by T of S. See, the problem itself, they will specify theta of S by T of S. Sometimes they will specify theta 1 of S divided by T of S. Okay, sometimes the problem will be specified as theta 1 of S divided by T of S. So based on that, you have to find out the transfer function.
Sir,
What man? Hello?
in yesterday, like that assignment, we have taken like the free body diagram of dashboard also.
Okay.
So like now in this question, why we haven't considered that?
Which one? Dashpot.
Yeah, dashboard. Like for
Yeah.
that also, like why we haven't drawn the free body diagram of dashboard now in this like previous example.
In the same translation system and the rotational system, only the difference is, only the displacement is the difference. So there
Yes,
it is a linear displacement. Rotational, it is an angular displacement.
no, sir. Like I'm asking, in yesterday the assignment question, we have considered the free body diagram of dashboard also we have included.
So yesterday diagram, shall I
Yesterday
show the assignment problem, right?
Yes, sir. Yes, sir.
Shall I show the assignment problem? So this is the assignment problem I given to you, right?
Yes, sir.
Yes, here the dashpot is given, B2 is given.
No, like sir, for the dash part also we have drawn the free body diagram, right?
Dashpot also free body diagram.
Yes, sir. In that
The
assignment,
first one is right, the first one. You can able to see the screen. First, this is
yes,
the first
sir, yes.
free body diagram.
In the second free body diagram which we have given in
The
figure
second
3,
free body diagram, M is 0.
the dash part only, no, sir.
Yes, FBT also connected with that. See, B2 also connected.
Yes, sir.
B2 also connected. B2
No,
also
sir. Like
connected.
no, I'm asking like when we have to consider the dashboard and when we have like in the in the rotational example question, sir. Once open that one.
Rotational
Today's
system.
one. Yeah, 2 days. Yeah. So here also we have a dashboard, right?
Here also they're having the same dashboard. Char 6 is same. So you see
Okay.
the T is applied. Theta also applied. But B
Yes,
is
sir.
opposing. B is opposing force. Sorry, here it's opposing torque.
Yes, sir.
Okay, so T and theta terms are applied one and B is opposing one. So this B, K as well as the moment of inertia J are all opposing side.
No, no, sir. Like today's question you open once. Like today example we have what we have. Yeah,
Which one?
here a dashboard is there, no, sir. B.
B.
Why we are not drawing the free body diagram of B also?
We have considered the B in J2 free body diagram.
Okay,
We have
okay,
considered
sir.
that. See, this is a good question, man. We understand this. The B plays a role. The B significant only for J2 system only, not come for J1. Because when you consider J1, only assume only you have to look out the J1 system only. If you consider the J1, what are all the terms? T and K. Here the two elements only directly connected. For J2 only, B is directly connected. So in the first free body diagram, see that there is no B term. J1, there is no B term. But for J2 only, we are considering the TB, T suffix B.
Okay, sir.
Okay.
Sir,
So
if J2 is not there, then we will consider a dashpot as a free body diagram and
in
obtain.
J1. So suppose in this
So then
problem,
in J1 it will be T, K, and dashpot. Three
yes,
of them.
correct. Exactly, man. Correct answer. If there is no J2, what will be happen? T, K, and B. If there
All
is
of them
no
are
J,
connected.
all of them are connected to the J1 system.
Okay, sir. Like the free body diagram, now then we will draw for B also.
Yes, you have to consider while you are drawing the free body diagram, you have to consider the B also in J1. Suppose if there is no J2, if J2 is
Okay.
absent, see, suppose if the J2, that is the pointer. Sorry. If there is no J2 means what will happen? J2 is not there. What will happen? Immediately B will be act on J1.
Yes, sir.
So while you are drawing the free body diagram for J1, Tk, you have to consider the T, you have to consider the K, you have to consider the B term.
Yes, sir.
Your doubt is clear?
I'm asking, sir, like here for J1 also we'll draw the free body diagram, and for
J2.
only B also we have to draw the free body diagram.
No, for only B not you to consider. So you have to consider only the node. J1 is the node. J2 is another node.
Sir, but
Where,
in yesterday assignment problem we have drawn for both, no, sir.
where the M is 0. You have to assume that M is considered as a 0, second node. So
Here
this is
also
the
we consider like J is 0, like
here,
another is 0,
no,
and I can draw for that.
here the problem is only one M.
Yes, sir.
And there are
Like
two fixed points, two reference points. See, what is the
suppose.
reference point? This is the reference point.
Okay,
Fixed
sir.
reference point. See, another one reference. Can you able to see the screen?
Yes, sir. Yes, sir.
There are two reference points. That's one, the first reference point, and second reference point M is 0.
Yes, sir.
So that's only you look at the reference point also. This is the first one reference point, and this is the second reference point.
Okay, sir. So,
So
like for
for
reference point, we'll consider like an object, and from that we have to draw the free body diagram.
free body diagram. First reference point, you are considered the M. For second reference point, M is 0. There is no M. That's
So, like
one. We are,
figure 3 is with respect to the reference point.
figure 2. The figure 3 is respect to the reference point. That is meeting point. The free body
Like
diagram
it is
meeting point.
means this is the reference point we are assuming this figure.
Yes. From this
Okay.
reference point, based on that, you have to draw the free body diagram.
Okay,
And
sir.
for other remaining diagram, we have only one reference point.
Okay, sir.
Okay. Any doubt?
Mm.
Shall we move on to the rotational system? Any doubt in this assignment problem?
No, sir.
It seems like the problem will be very simple, but if you analyze that, this problem is very, very not complicated. You have to use your thinking how to solve this problem. That's only the assignment problem will be look like very simple problem because there is only one mass. But actually, what behind the scene is, it consists of two reference points. Okay.
So node means what? Like actually.
Node means it is a connecting element. So node means how many elements? That is, a node means it is a junction point. What are all the elements connected to the junction point?
So
since
the of node we have to draw.
You have to, based on the node point, you have to draw the free body diagram. But here it has given the two reference point, but the node is 0. That is, main node is 0. You have studied the circuit analysis. You have considered the two node. One is a reference node, another
Yes.
one is main node. Okay.
Yes,
So
sir.
only in the circuit analysis, only one point as a reference point. There is no more than one reference point. Very
Yes.
rare cases will consider the more than one reference point. But I hope that in circuit analysis only one reference point. But for the
Yeah.
system, you see that this system it consists of two reference point, one main node, two reference point. So what we are how we are solving the problem? The another we are taking the reference point as it is, but the main node is considered as 0. That's why M equal to 0 for the second case.
Okay, sir.
Okay. M is 0, main node is 0, but the reference point is as it is, we are taking another reference point, new reference point.
If suppose in this question, if K is not present, then we have to consider the reference point or not.
If K is 0, B is present.
Yes, sir.
You have to consider the first reference and B as well as M.
So then in the example question, what we have discussed today, so then why we have, okay, sir, I understood.
You understand? Shall I go to the rotational system?
Yes, sir. Yes, sir, understood, sir.
So this is the example we have. This is the solved problem, right? This is a solved problem.
Yes, sir.
So
So,
J2 is not there means J.
here we need not to consider this reference point.
No, here consider only one reference point. So there is no problem. If there is two reference point means you have
Yes,
to
sir.
consider that particular reference also.
Okay, sir.
Okay.
So like why we have to consider that, like
Because
what
reference point means it is a reference one. Based on the reference only we are analyzing. It is a fixed point.
okay, sir.
So in a circuit analysis, what is my reference point? All the elements have a one common point. That point is a ground element. It is considered as a zero.
Yes, sir.
Right? So exactly the same thing. Mechanical system reference point is it is a common point for all the element, which is a neutral point. That is a 0 point.
Okay, sir.
Because J1, J2, K, B, everything it is a positive magnitude. We need one zero system, one neutral point for that positive system. So for that only we are considering the reference point.
Okay, sir.
So shall we go to the tutorial problem for mechanical rotational system? So have you drawn this system? 1.6, sir. So it's a very simple problem. Here only one reference, and as usual, it consists of instead of two masses. Here there are two moment of inertia, J1 and J2. Same procedure. First, consider only the J1. Draw the free body diagram for J1. Write the differential equation for the each term, that is each element. Add the differential equation. Then go to the J2. Draw the free body diagram. Write the differential equation for the each element. Then find out theta. Then after that, apply the Laplace transform. Find out the term theta of S divided by T of S. So this is your assignment 2. I expect today night before 9 p.m. post the answer in the assignment 2. Okay.
So like what actually the function of the dashpot?
Function of the dashpot 2 represents the friction.
So
Friction.
like here it will represent the rotational friction, like or
Yes,
linear.
rotational system also have some friction.
Okay, sir.
Here it is angular. It is angular. It is not a linear.
Yes, sir. Yes, sir.
So the displacement is angular. Friction means that is not a point of a linear friction or a angular friction. It represents a friction quantity. V represents a friction.
Yes, sir. Yes, sir.
Rotational frictional coefficient. So the friction will be present everywhere, whether it is a linear or rotational. For we are understanding it is a rotational friction. Friction will be present in both linear system as well as a rotational system. Okay.
Yes, sir.
That's only they have not specified B suffix R, B suffix T. That is a translational rotational. The B is common for rotational as well as translational. For our understanding, we are specifying it is a rotational friction, translational friction. But you see that the B is same B we are using in translation also. Suppose if there is, as per your point of view, rotational friction, translational friction means they will specify as B suffix R, B suffix T. That is translational friction and rotational friction. But dashpot is common for B is common for both rotational as well as translational.
Okay, sir.
Your doubt is clear?
Yes.
In every system we have dashpot, every system we have K. The only thing is J is different for rotational. That is the displacement is different, and there the X is linear displacement is different.
So like in assignment problem for the dashpot, they have mentioned a reference point. Like in such case, like it is a linear friction.
Yes, that is friction is same. B is same. We are understanding it is a linear friction and a rotational friction, translational friction as well as rotational friction. Here also you have to express the same term. B and K is same. Instead of X, it is changed to theta. Instead of F, force is changed to torque. T.
Okay, sir.
So have you copied down this diagram? So today night 9 p.m. you have to submit this as assignment 2. Assignment 2 also I will award the mark, but assignment 1 is the main assignment for considering for the mark evaluation. Considering for the awarding of the mark, assignment 1 is the assignment 1 mark will be considered for the evaluation. Assignment 2 also I will award the mark, but this is not considered as a main assignment. This is for your practicing tutorial 2. I hope everyone please post your answer before 9 p.m. today. Okay. Any difficulties? So please copy down the problem. Theta of S by theta T of S.
So there are 4 connecting elements of J1, है ना?
J1 T theta 1. There are 5. There are 5. T
So
theta
T
1.
T1 K B12.
There are 5. Anyone can answer for this? I am
T-
telling it is a 5.
TJ1.
So it is a 5 or 4. First of all,
Sir,
first come to the
4 only, sir. 4 only.
5, sir.
yes 5. How? Yes, tell man 5. How is
Sir,
the 5?
Opposing force TJ1.
Yes, exactly. T J1 also have to be considered.
Sir, why
Yes,
TJ1? Sir, only T na T theta 1 K B12.
Yes, you have to consider the moment of inertia J1. From J1 also some opposing force. T theta 1 is a applied force, applied torque. T theta 1 is a applied torque. T J1 B12 K are opposing torque. So in a free body diagram, there are 5 elements.
And sir, in J2 also 5 only, na?
1, 2, 3, 4, 5. Yes, exactly 5.
Okay, sir. Okay, sir.
In J2, how will you consider? In J1 and J2, how will you consider for K B12? The joining elements should be considered as the theta 1 minus theta 2 or a theta minus theta 1, and a K1 minus K and a K minus K1. That's as usual. For J2, same thing, 5 elements. Shall I show the free body diagram?
Yes, sir.
See whether you have completed this diagram, whether you have
Sir.
drawn this diagram, full diagram you have drawn
Sir,
this.
yes, sir. Yes, sir.
Yes, anyone? Still you are
Yes.
still you are drawing
Yes,
this
sir.
diagram.
Sir, wait, sir, 1 minute.
Okay, man. I'll wait for you. You first draw this diagram. I will show the free body diagram for J1 and J2. Final answer you have to post in the assignment 2.
Sir, like why for electronics, like this mechanical problem?
Oh, yes, ma'am. Correct. Exactly. Good question. Say, this is the control system especially suitable for your electronics and communication as well as electronics and instrumentation. Okay. We are starting from the mechanical system and next we are traveling to electrical system. There we will understand what is the concept related to electrical and electronics. Because the control system is a multidisciplinary subject. EC also you need the control system while you are designing antenna, wireless devices, you need the control system. So we are
But sir,
starting
it is
from the,
necessary to, sir, it is necessary to study mechanical system.
yes, because everywhere we are starting, the initial point is a mechanical system. From the mechanical only we are moving to the electrical system. Okay. So first you have to
Okay, sir.
understand what comes from. Because of the same concept in the circuit analysis, resistance, capacitance, inductance. Here you are studying mass, spring, dashpot. Similar to this, next you are going to see resistance, capacitance, inductance. So from the mechanical system, the first thing is initial one is mechanical system. Next you are transforming to resistance, capacitance, and inductance.
Sir, what is dashboard, sir?
Dashpot. That's why dashpot is used to represent the friction.
Okay, sir. Okay, sir.
Friction. Every
Okay,
system you
sir.
have the
Diagram
friction.
finished, sir.
Diagram finished. Shall I move to the first free body diagram J1?
Yes, sir. Yes, sir.
So there are 5 elements. So one boy asked how it is 5. One boy replied the answer, yes, it is 5. So I hope you got the answer. So you take the free body diagram and take the differential equation. Next I will show J2 final expression
Okay,
T of S by theta of S by T of S. You have to post in the assignment.
Okay, sir.
So draw the free body diagram for J1. I will draw the free body diagram for J1.
Yes, sir. Finished, sir.
Okay. Shall I move to J2? So J2 also consists of 5 elements, sir. That is 5 terms, sir. One is applied one, remaining 4 are opposing one. To understand the meaning, the arrow mark indicates applied as well as opposing. Clockwise, it is applied torque. Anti-clockwise, it's showing the opposing torque. So if you finished means tell me, I have to take the attendance in front of you itself. Just don't sign out now. If you finished means tell me, I will record the Google attendance. So before that, don't sign out.
Finished, sir.
Okay. So your duty is you have to post the assignment today. Only theta is by T of S. What is the answer? Okay. So everyone finished? Shall we wind up?
Yes, sir.
Sir, please share this PPT.
Definitely, man. I will share the PPT. Definitely, I will share the PPT.
Yes, sir, before 9 p.m., sir.
Before 9 p.m. Okay, man. Stay. I'm taking the attendance.
Then what does that question mark mean, sir, in that attendance?
Which one? I don't know, man. Why it is showing the question mark? Just to see, opening the Excel in front of you, you see that screen.
Okay, sir.
Can you able to see the Excel sheet?
Yes, sir, we can.
See, there is no time. Some of them have timing, some of them not having timing. Only 3 minutes. Some of them it's showing a correct attendance. See, 65 minutes. See, this also 65 minutes. Anirban goes. These are all your class.
Yes, sir. I am Anirban Ghosh.
Anirban goes. Anuradha. These are all showing the attendance. So this attendance this shows that they are fully present. But see, some of them are Dinesha 0 minute and Chandra Prakash 0 minute.
Yes, I am in class only, sir.
You are in class only, man. But Google taking that you are not present. You have to question Mr. Sundar Pichai only.
Sir,
Fun, sir.
Okay, man. No problem.
Sir, you can take manual attendance, sir.
Manual attendance. Yeah, I know, man. Okay, you can sign out. Okay. So solve the problem. I will share the PPT.
Yes, sir. Thank you, sir.
Okay. Sign out, man. Thank you.
Thank you, sir.
0.0%, sir.
Okay. Sign out. Please sign out.